Hi and Assalamualaikum guys. My name is Muhammad Syafiq bin Yusof. I am from UNIK Almiat, University of Kuala Lumpur, Malaysian Institute of Aviation Technology. So today I would like to teach you about physics and aerodynamics. So this is the subtopic of optic lights, and the first subtopic is nature of light. Light waves are part of a group of electromagnetic waves or radiation that include X-rays, ultraviolet, infrared rays, and radio waves. They carry energy from one place to another, and on absorption cause a rise in temperature of the absorbing body. The second subtopic is light dispersion. Within the light spectrum, there are 6 colors that can be readily identified: red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. Sir Isaac Newton was the first person to explain this band of colors known as the spectrum using a glass prism. So the next is color combination. Objects appear color because their surface will absorb some of the frequencies and reflect others. Red, green, and blue are known as light primary colors as they cannot be created. Secondary colors can be created by mixing two primary colors. So the next is reflection. Reflection is the change in direction of a light wave when it bounces off a boundary. There are two laws of reflection. The angle of incident I is equal to the angle of reflection R, and the reflected ray lies in the same plane as the incident ray and the normal at the point of incidence. This law of reflection applies equally to curved and flat surface. A curved mirror are combined of two types, concave and convex mirror. A concave mirror is a surface that is shaped in towards the middle and away from the observer. A convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. So the next is reflection. A change in direction of the light ray occurs when the light rays move from one medium to another. Example, from air to water. This is called refraction. The direction in which they are reflected depends upon whether they move into a more dense or less dense medium, and respectively slow down or speed up. And then light refractive index. The refractive index N depends on the wavelength of the light. In a vacuum, light travels at 300,000 km per second, while in a glass, the velocity falls to 200,000 km per second. And the next is Snell's law. The ratio of the sine of the angle of incidence to the sine of the angle of refraction at the boundary of the two substances is always constant. And the next is lens. There are two basic lenses, convex lens, or also known as converging lens. The other one is concave lens, or known as diverging lens. How an image appears when using a lens can be obtained by drawing two of the following rays. A ray parallel to the principal axis which is refracted through the focal point F. A ray through the optical center O, assuming no deviation caused by the lens thickness. A ray through the focal point F, which is refracted parallel to the principal axis. So this is the formula: 1 over F equal 1 over U plus 1 over V, where U is the distance of an object from the lens, V equal distance of image from the lens, and F focal length of the lens. So then is electromagnetic wave. Electromagnetic wave consists of coupled electric and magnetic fields that vary periodically as they move through space. Radio wave, light wave, X-rays, and gamma rays are examples of electromagnetic wave. In free space, all electromagnetic waves have their velocity of light, which is c equal 3 times 10 power of 8 meter per second equal 186,000 miles per second. So this is a characteristic of light. Light travels in a straight line. It spreads out as it leaves the source. Reflection. The angle of reflection is the same of the angle of incidence. The image has the same size and shape but with left and right reverse. The object also has the same distance behind the mirror as the object in front of it. Refraction: when light passes from one medium to another, its velocity is different and its direction changes. If it goes from high velocity medium to lower, it bends toward the normal and vice versa. Light moving along the normal is not deflected. And the last one, apparent depth. An object submerged in water appears closer to the surface because the light leaving the surface bends away from the normal as it leaves. The object also seems show lower than it actually is. The ratio of apparent depth and the true depth is equal to refraction index of liquid and refraction index of air. So, for the last subtopic of optic lights, I will tell you about the formula. Length equation: 1 over P plus 1 over Q equal 1 over F, where P equal object distance, Q equal image distance, and F equal the focal length. Positive P or Q equal real object or real image. Negative P or Q equal virtual object or virtual image. Magnification: M equal H isotropy over H equal Q over P, where H isotropy equal image height, H equal object height, P equal object distance, and Q equal image distance. Positive M or H and equal an erect or straight image. Negative M or H equal an inverted image. And then we continue our lesson to the new topic, sounds. So this is a subtopic of sounds. So the first subtopic for sound is sound intensity. It determined by amplitude of the sound wave. The higher the amplitude, the higher the sound. It measured in decibels or dB. 1 dB is the smallest change in sound intensity the human ear can detect. And the next is frequency, the number of vibration complete per second. F equal 1 over T, where T equal time in second. Unit hertz or Hz. Higher the sound, so higher the pitch. And then is sound propagation. Transmission and reception of sound is source, medium, and detector. Range of human can hear 20 to 20,000 Hz. And the next is Doppler effect, the apparent rise in the pitch or frequency of a sound as its source approaches the hearer and the decrease in pitch as the source moves away. The next is sound vibration. It causes waves which radiate out from their source at the speed of sound. Aircraft move less than speed of sound. The sound moves ahead of the aircraft. Aircraft flies at the speed of sound, produce shock waves. Speed of sounds, the speed at which the mechanical vibration of sound travel in an elastic medium, varies the temperature and altitude. And then is Mach number, the ratio of the speed of the airplane to the speed of sound in the same atmospheric condition. Mach number equal speed of the aircraft over speed of the sound. The next is resonance. The natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move too. It has a destructive force. So this is the conclusion of the chapter sounds. Wave property. The period T of a wave is the time required for one complete wave to pass a given point, and thus frequency F equal 1 over T with its unit hertz or cycles per second. The wavelength lambda is the distance between adjacent wave crests. Wave velocity V equal frequency F at wavelength lambda. The amplitude A of a wave is the maximum displacement of the particles of the medium through which the wave passes on either side of the equilibrium position. The intensity I of a wave is the rate at which it transports energy per unit area perpendicular to its direction of motion. And the next is sound. Sound waves are longitudinal waves that consist of varying pressure. They can travel through solids, liquid, and gases. The region of sound wave consists of regions of compression and rarefaction that follow each other. The change in pressure causes our eardrum to vibrate with the same frequency. This produces the sensation of sound. When sound waves spread out uniformly in space, their intensity decreases inversely with the square of the distance r from the source. Thus, if the intensity of a certain sound is I1 at the distance r1, its intensity I2 at the distance r2, it can be found from I2 over I1 equal R2 equal R1 over R2. And then is Doppler effect. When there is relative motion between a source of wave and observer, the apparent frequency of the wave is different from their frequency f at the source. This change in frequency is called the Doppler effect. Example 1. Navigation radar equipment use radar to detect intensity of the cloud, give signals and bounce back. Police radar guns that send out pulse of short wavelength radio waves that are reflected from a moving vehicle. And the last one is Doppler effect. In the case of sound wave, the frequency f is given by f equal f source plus v times by v over vl over v minus vs, where vl equals sound velocity of the listener, vs equals sound velocity of the source. And the end. Okay, that's all from me. Thank you. I'm sorry for my fault. Okay, that's all. Thank you. Assalamualaikum guys.